My name is Jamieson. I'm a geological consultant with Datamine software, and I specialize in Studio RM and our underground face mapping software, which is the topic of today's presentation, Studio Mapper. So some of you may be familiar with Studio Mapper already. For those of you, this should be a nice little refresher. If you haven't upgraded to version 3 yet, then you'll see some of the great new features which have been implemented with the latest release of version 3. For those of you unfamiliar with Mapper, maybe you're joining just keep across current softwares that are available, then this will serve as an introduction, and I hope to show you how Studio Mapper can increase the efficiency and the productivity of your underground mapping. So all I'll be doing today is following Mapper's focused workflow to create a map. Along the way, we'll see how Mapper can be configured with your site-specific information and preferences. We'll look at how data is stored in the local and central file databases and how data can be synchronized between the two. We'll look at how we go about capturing data of a number of different types. So pictures which we can map onto, actually drawing in our geology, structure, recording channel samples, which can then be easily uploaded to your geological database. Georeferencing all of that into usable real-world coordinates, saving and exporting your data. So we can plot your data automatically to PDF, and it will mimic the format of your existing paper maps, so you can still see the same information, your sample data, all of that. And then how we can use the data we're actually capturing downstream as well in an implicit modeling process. So there are a few key points that I want to emphasize along the way, things that I hope you notice. So with Mapper, you're capturing data digitally directly at the face, and then that data can then be easily transferred to a central network location where it can be used by others. So Mapper is designed to be able to be run on a portable Windows device, such as a Microsoft Surface Pro. For this demonstration, I'll just be using it on my PC, so you're perfectly able to do that. But obviously, its greatest advantage and utility lies in the fact that you can run it on a portable device underground. So with Studio's familiar interface and commands, it is easy to use. There's a low barrier to entry and a short learning curve, which is especially good for new starters and given the mobile geological workforce at the moment. We'll see how Mapper can be flexibly configured to your site-specific requirements and preferences. So geological logging codes, visual formatting, colors, labels, reports, all of that is designed by us for you according to your requirements. Then it becomes available for all users. So your maps are standardized and everybody has access to the same information. So this should increase your productivity, more maps per geologist per shift. We can automatically output your reports to a PDF format, which mimics your existing paper maps with all the information you want to see there. And then you can use your output from Mapper in the form of your mapped geological features to improve the accuracy of your geological models when they're implemented into an implicit modeling workflow, such as with our own vein modeling tool. Now, just quickly, I expect the live demo to go for 20 to 25 minutes. We'll have 5 minutes for Q&A afterwards. So we won't keep you any longer than half an hour, 35 minutes. Please feel free to leave questions in the chat during the presentation and I'll address them afterwards. Your cameras and mics will be off for the presentation. And yeah, I'm also happy to take any suggestions for future webinars if you have any ideas for things that you'd like to see with Datamine software. So before we look at Mapper itself, I just want to look at how it's configured. So here's my project directory, and here we've got this .mpcfg file. This can be opened and edited in any text processing software such as Notepad++. It's a very high-level scripted XML file, but don't let that scare you. It's quite straightforward. And this file contains all of the site-specific information for your Mapper implementation. So some of this stuff you'll be recording on paper maps at the moment. So who made the map? What's the closest survey station and how far away is it? Just the general properties behind the map. And these items can be restricted to lookup lists as well to avoid misentries and just maintain the integrity of your data. Further on, it describes which geological features you want to record, so geology, structure, and which attributes of those features you want to record, so texture, intensity, even dip and dip direction if you want to measure the orientation of your features and put them in here as well. Further on, we've got lookup lists. So, my list of authors, destination, ore waste, all your logging codes. So we will create this for you to your requirements when you implement Mapper. And once it's handed over, it's quite easy to amend, any staff turnover, or if you revise your logging codes, that can easily be changed here. It's really a simple matter of copying any one of these elements and pasting it, and then just changing the values. So it's very easy to update this file. Also in here, we've got a templates folder, which contains legends files, 3D overlay templates, plot templates, basically all of the site-specific formatting. So how do you want your geology to be colored, labels, line styles, all that information is contained here. Again, we create this for you to your requirements when you implement Mapper. Now, once you create your maps, the data is stored in an easy sort of file database system. So your maps are split by mine. Now this can be any level. It could be mine, it could be ore body, it could be level. It's really however you want to categorize your data. Within each mine, we can have multiple areas, and within each area are the maps that you've created. And then within each map, there is a variety of different types of data, and we'll look at how this is captured. So now to launch into Mapper. So straight away, you'll see the familiar studio interface if you've used any of our studio series before. Now on a tablet, you can navigate around the 3D window with your basic touch inputs. So you'd be able to pinch to zoom in and out. You can pan by dragging 2 fingers across the screen, and then you can use the spin function to spin around your data. Now, we've got all of the same viewing and sectioning controls as in our other studio products in the navigation toolbar here. So you've still got the ability to clip your data and define a section and sort of view your data however you like. Now, before you've even started mapping, one of the powerful things about Mapper is that you can import reference data in the form of your development wireframes, your ore solids, your drill holes, block model, and you can have all of that information available in the 3D window at your fingertips when you're underground. So obviously, if you can sort of locate yourself in your development wireframe, you can see what drill holes are nearby. You can see where you would expect your ore body to be. You can view grades with a block model. So you've got all this reference data to hopefully better inform your expectation of the geology in your area, and hopefully enable you to make better decisions on the spot when you're underground. Now, to start making a map, we just tap Add Map. Now, you can pre-populate the map name box here with a given naming convention. So obviously you want people to be naming their maps correctly. So you can put in a default naming convention to remind them exactly what they need to put in what format. We can choose which map type we want to make. So we've got options here. We can just record the face. We can record a full heading, which is the front, the walls, and the backs. You can even include the floor if you like. And all of that is specified in the configuration file as well. So you can add additional map types there. For this demonstration, I will be just making a full heading. So the face, the walls, and the backs. Now you can use the laser disto to get accurate measurements of your cut. So width, height, depth. It's recorded what I used last, so I'm just going to continue with the same ones. Now, when we create a map, it takes us out of the 3D window and into a mapping window. So this, if you look at the coordinates on the bar at the bottom, the X, Y, and Z, it's just close to 0, 0, 0, the origin point. So this isn't in world coordinates yet, but we will be georeferencing it into real world space down the track. So here we've got this kind of grayed out box with a face, 2 walls, and a roof to represent our heading. Now, the headline improvement with version 3 was the ability to explode this 3D shape into a nice 2D surface. And when you're mapping on a tablet, this makes the process of drawing in your features a lot easier. There's no longer any need to kind of manipulate this box to map on each surface. You can just draw onto a nice 2D surface. Now, the first step to our data capture is just to put in the map properties. So who made the map? Oh, sorry there. I'm not sure if that's wigging out for everybody. I'll just give it a moment. Okay, that seems to be better. So I'll put in the nearest survey station and how far away it is. Let's say 18 meters. The lab submission ID, so it's nicely pre-populated with whatever prefix you need there. Where this material is going to be sent to, which stockpile or a waste. Again, you can have as many things in that lookup list as you like. And any comments or additional information you want to leave. Now, because we're going to be drawing closed shapes to represent our lithologies, to help that, we just want to put a simple outline around each of these surfaces, which we can intersect with our strings. So on my face, I'm just going to put a simple arch, and that's automatically resized to the dimensions of the cut that we entered earlier. And on each of my other surfaces, I'm just going to put in a rectangle. Another thing about version 3 is that you just need to tap on each of these surfaces to make them current. For users of previous versions, you'll know you had to select which surface you're mapping onto here. Sometimes you might forget and map onto the wrong surface. Now it's a lot easier. There we go. So now I've got profiles on the front, left, top, and right. So the next step is to import a picture of your face to map onto. Now you can just map onto a simple grid if you like. If you're unable to get a good quality photograph, you can take a photo with the portable device, although typically their cameras are pretty poor quality. So you may wish to take a proper camera underground, take a good quality photograph on that, connect it to your device, and just import the photo from there. Now that I've imported that photo, I'm just going to resize it to the dimension of my drive. And that looks pretty close. And we can hide that grayed out plane so we can see more easily what we're doing. And for my walls and the backs, I'm just going to map onto a grid. So now we can draw in some geology or any features that we want to map. To do that, we just draw in basic strings to represent our lithological contacts. Now we want those strings to either cross the boundary profile or cross each other to create closed shapes. So I'm just going to start, I can see something pretty clearly in the middle there. I'm just going to start near the bottom. Just want to disable my auto snap first, and I'll start that again. So I'm just going to start near the bottom and then draw one continuous line for one contact of that feature. And the great thing is, when you cross from one face into another, you can just keep going with one smooth, continuous line. Now I'll do the other contact. Now, the strings don't need to strictly cross each other. If they are close enough within a tolerance distance, it will still generate outlines. So now I've got some closed shapes here. I've got my vein, my hanging wall, and my footwall. I'm going to generate some outlines within each of those closed shapes. So at the moment in this window, I've just got a couple of contacts, a couple of plain lines, and now I'm going to generate some polygons within each of these shapes for each of my lithologies. I won't get too crazy with the detail on this map. With Mapper, you can go into as much or as little detail as you like when it comes to drawing on these features. You can draw as many little lines and squiggles as you like or as you need to capture your geology in sufficient detail. So now that I've generated these shapes, I'm going to assign each of them a lithology, and you'll see as I tap on each shape here, it becomes highlighted in the 3D window. Okay, now I've just recorded lithologies. We can record additional attributes such as texture. I won't do it for all of them, but this is just to demonstrate that you can. Basically, any features, attributes that you want to record can be put in the configuration file and then recorded in your map. Okay, that'll do. So I've recorded all of my main lithologies now. Now I can go ahead and put in some structures. Now, maybe you've got structures actually separating your lithologies, in which case you can draw a string in structure and then generate your lithologies on either side of that. I'll take a little artistic license here because I don't have any pictures, but I'll say I can see something in the wall there, and it comes down into my face, and I'll assign that a structure. Again, so we can record intensity, dip direction, if you want to record those measured values as well. Now, in the case that we want to record something directly from our walls to the roof, we can just count on the grid here how far along it is. So that's about, what, 40 centimeters. And then we can carry that on, extending that line in the roof. And I can throw in some structural measurements as well. Okay, so now I've recorded my geological features. You've also got the ability to draw in sketches. So if there's anything additional you want to convey, I could put in some little arrows to show the offset along a fault or a shear. I can even put in comments. Got my snapping wrong there. Problem with trying to talk and do at the same time. That's just something to do with my snapping. I won't go into it too much now, but you can leave comments as text, which will appear on your map. For example, if you want to write, there's so much displacement along this feature. And the last step to capturing our data is to put in some channel samples. So you can set the sample prefix and which is the next sample number in your sequence. And then to put in a channel, it's as simple as drawing the start point and the end point. Now, you can manually adjust these lengths here. So I know my map was 5.1 meters across, and you can easily tap to insert additional samples. So obviously you don't want your samples to be too long, and you want to put in a new sample at any lithological boundaries. Again, if I'm not happy with any of those placements, I can easily drag those points, or I can manually edit them here. Now we just record each of our lithologies, just like logging a hole. Put in any additional comments. You can record estimated grades. If you want to put in a QA/QC sample after your mineralized zone, for example, I can insert a duplicate. And while you're playing with your samples, if you happen to put them out of sequence, here I've got 32, 35, 33, I can just enter what the first number was again here and quickly reorder everything with a touch of a button. So now I've captured all of my map data. I want to bring this into georeferenced coordinates. Now, there are a number of ways to do this. Basically, what we'll be doing is picking one or two points in our map and then picking where those points lie in the real world. There are a number of ways you can determine where in the real world it could be. The simplest is, just change my snapping. Sorry there, give me 2 seconds while I figure this out. There we go. Just had to right click to snap. Now, if you can easily determine where on the wireframe your map should lie, so if this pickup was only taken yesterday and I know this is where I mapped, I can simply pick on there where my map is. Now, you'd typically do the mapping maybe on the desktop once you've come back from underground. It's easier to do it than on a tablet. Now, again, I'm not sure if my map played ball. Another way that you can georeference it is if you have a survey point. Just find where my other maps are. Perfect. Say I've got a survey point and I'll just put in a dummy point here. There we go. And that's my survey point. I know my map is 20 meters away from that point. I can easily draw a circle, 20 meters. And I can then see where that circle cuts my wireframe and use that to georeference the map. And I'll demonstrate that now. There we go. And if you want to fine tune the orientation, you can easily just spin that a little bit. Done. So now I've given my map real world coordinates. I can export this data. So we looked at the local database before, but now I want to update that to the network. So through here, we can specify the file path for our central database. Typically, that'll be your, pardon me, your network. Although for this demonstration, I will just pick another location on my C drive. We can filter the data. We're synchronizing by mine, by area, and by dates. And then we can update the central database with any new or edited data. Alternatively, you can update your local project with any new data from the central network. And now, if I go to that central database, I can see I've got my newest data from today. Nope, I haven't saved that yet. First, I need to save my project. Done. And now, if I sync that, we should see some additional data here. So what have we captured? In this properties file, we've got the sort of metadata behind the map that we captured. So you can use this to see who made the map, what was the submission, where did this material go. We've got our geology and structure strings as in the features folder. We've got a georeferenced photograph, and we've got our channel samples in the format of a Datamine drill hole file. So that's exported the data on a map by map basis. We can also export all of our maps to single files for each of those different types of data. So instead of having a different stream file for each map, we can export all of that together. I'll send that to my central database, to the Area 1 folder, and I'll export all of my data for Mine 1, Area 1. And now if I go and look at those files, I've got my channel sample data, which has been exported as CSVs for assays, collars, surveys. The collars and the surveys will probably be the most important. So you can now take those CSVs and import them to your geological database, awaiting your assays to come back. And in our geology file, these are all of the strings for all of the maps in that area. Likewise for our structures and our channel samples. So all of that information is now stored in a single file, which you can then easily import to Studio RM. Now we can export our data as a plot. So this can be configured to be in the same format as your existing paper maps, with all of the same information. So your basic, who made the map, where did the material go, the sample data, as well as pictures of your map features. And this panel sort of gives an overview of, whereabouts in the mine the map was taken. So now we've georeferenced, we've exported that data, and the last step is to just take a quick look at how this data can then be used. What is the advantage of capturing this data digitally? So without going into the implicit modeling process, if we look at, here is our ore wireframe, and just let me bring in some other map data. So here's a previous map. We can see here our contacts. I'll just hide that picture so we can see the map. So here we've got a map that was made previously. We've got an ore solid wireframe. Obviously we can see maybe this was taken, we didn't have a drill hole going exactly through there. What we've observed is quite different from what we've previously modeled. Now in RM, you can take these footwall and hanging wall strings and use them with the implicit modeling vein tool to force your wireframe solid to go through those lines. And when that's done, we can see here was our hanging wall before. Here, this second red line was our hanging wall after, and we've significantly changed the location of that. So we've really increased the accuracy of that model. And while that's probably cut out quite a bit of material, at least we know exactly what's happening there. So that's why it's quite powerful to record this data digitally, so you can increase the accuracy and reduce the risk in your geological models by using that observed hard data. So that's all for the mapping workflow. Thank you for listening.